Hey scholars, it's Mrs. Gregerson. I just wanted to work a few of these problems that people normally struggle with on the homework. Just a couple heads up on this. If you don't need help on the problem, fast forward. Don't watch. Not a requirement. If you just want to have it as a refresher, great. But let's go through and let's work with the volume formulas. Remember, cones and pyramids are really very similar to cylinders and pyramids, except for they're all divided by 3. So it makes it really easy for us to do. Now, remember, you should know your formulas. So for instance, it says find the volume of each pyramid. It says no decimals unless decimals are given. So basically write this in simplest form. But we know the volume of a pyramid is area of the base of the pyramid times the height of the pyramid all over 3. But if you notice here, we don't know the height, but we can calculate it. So a few things we've got to do. Number 1, we know we have to draw the base of a pyramid or a prism. So we draw it. If they don't tell you otherwise, it's understood to be a regular pyramid. So I know this is 10, 10, and that's going to be a square. You calculate the area of the base. That's just going to be side squared. So 10 squared equals 100. I have to calculate the height, and I'm going to use the fact that the apothem of the base, the height, and the slant height make a right triangle, and we're going to use the Pythagorean theorem. So height squared or leg squared, right, because it's a right triangle, plus a leg squared equals the hypotenuse squared. So height squared plus 25 is equal to 144. Subtract the 25, height squared is equal to 119. If you take the square root of that, it is not simplifiable, so it's just the square root of 119. Now we just plug it into the formula, the things that we have. The volume is the area of the base polygon times 100, which is 100, times the height, which is the square root of 119, all over 3. So my final answer is 100 times the square root of 119 all over 3, and this would be in cubic meters. All right, next problem we're going to look at, number 7. A lot of people don't like number 7 because they don't like the fact that we have icky looking radius for this one. So first of all, let's just think about what is the formula for the volume of a cone. Well, the volume of a cone is pi times radius squared times the height over 3, or you can say 1/3 times the quantity, pi r squared times the height. I'm going to actually use this one this time because I know I'm going to end up having a fraction for my radius. So with this, I have to find the radius. Well, the diameter is 7, so my radius is going to be 7 over 2. And then it's just got to plug it in. So this first one, we're going to use the 1/3 formula. So I'm going to go over here. I'm going to go 1/3 times pi times the radius, which is 7 over 2 squared, times the height, which is 9. So we get 1/3, and I'm going to write that as pi over 1. 7 over 2 squared is 49 over 4. And we're going to have 9 over 1 here. So the reason why I made everything into fractions so it's easier to reduce, because notice the 3 can go into the 9 3 times, and then we just multiply it together. So that's 147 pi. Numerator multiplies together all over 4, and that'd be cubic inches. You're also supposed to find it to the nearest cubic inch, and if you punch that into your calculator, it'd be 115 cubic inches. So we need both of those answers. All right, next problem, my friend. This is actually doing the same thing as problem number 7. It's just in a word problem, and it says the following. This funnel has a filter that was being used to remove impurities from a solution, but became clogged and stopped draining. The remaining solution is represented by the shaded region. How many cubic centimeters of the solution remain in the funnel? So basically, I'm looking for just the blue. Now, this is actually a precursor to some calculus problems you'll see someday, so it's kind of cool. But the formula for the volume of a cone, we know, is 1/3 times pi r squared times the height. Because remember, pi r squared is really the base of the cone. So what do we know? Well, our radius is going to be 3/2 because the diameter is 3. How do I know the diameter is 3? It's smack dab in the middle. That's how we know. All right, so let's plug our stuff in. So we get 1/3 times pi times 3/2 squared times the height of 2. Notice the arrow is going to the height, so we know that's where it is. And then we just go ahead and multiply. 1/3 times pi over 1 times 9/2 squared is 9/4 times 2/1. Oh, look. The 2 and the 4 can simplify. Then you multiply the numerators together. And we get here 9 pi all over 6. Oops, guys, I forgot to simplify. Oh, look. That becomes 3 pi over 2, and that would be in cubic centimeters. All right, I'm just cranking these out because these are a lot of the often missed problems. We're going to look at number 11. Now, number 11 is a divide and conquer problem. You need to understand you have a pyramid with a square base, and then you have a rectangular prism with a square base. So the base stays the same no matter what. So let's redraw the base, and we know it's going to be 24 feet on every side, and we have to find the area of the base, which is going to be side squared. So 24 squared, I do believe, isn't that 576? Double check myself since I don't have you guys in class. Yep, it's going to be 576. All right, now we need to do the volume of the pyramid, right? And we know that formula is area of the base, base polygon that is, times the height of the pyramid all over 3. So we get 576. The height, they tell us, is 9. That's all over 3. So 576 times 9 divided by 3, that's going to give us 1,728, and that's going to be cubic feet. But now we have to find the volume of the prism. Well, we know that's also area of the base times the height. Well, the area of the base was 576. The height, my friends, is 15. It's the length of its lateral edge. So we just go 576 times 15, which is going to be 8,640. And so then we're going to get the following. Oh, that's in cubic feet, but now we just have to get the volume total here. And we just add the two together. And my friends, we should get 10,368 cubic feet. All right, let's keep cranking these out. Okay, guys, we have some, I can't wait, work backwards problems that we are going to use. This time they want to know a number 12. We have a regular pyramid. Remember, if they don't tell you what type of pyramid it is, you assume that it's regular. It is a regular pyramid with an equilateral base. And remember, with pyramids and prisms, we always redraw the base. And we know these are all x. But for the volume, because we're working backwards, we know it's the area of the base times the height all over 3. Well, I still need to know the area of the base. Well, isn't that formula of an equilateral triangle side squared root 3 all over 4? So it's going to be x squared root 3 all over 4, right? So I'm looking at this and I'm like, ooh, fraction. We're going to change to this formula. So we get 1/3, and we get x squared root 3 all over 4. Oops, I forgot my squared there. Times the height of the actual pyramid, not the base. That's 6. All right, so I'm simplifying this right away. I'm seeing this is going to be Oh, actually, I totally forgot to say what our volume was equal to. Here's 18 root 3. Sorry, guys. I'm going to go backwards here a little bit. I get so excited sometimes. Okay. Wouldn't you agree with me? The volume for this is 18 root 3. So let's just do a quick simplifying in the process. So I get 18 root 3 is equal to 6x squared root 3 all over 24. Remember, multiply the numerator, denominator together. I'm going to simplify a little bit more. 18 root 3 equals x squared root 3 all over 4. And now I'm going to start solving for stuff. So I'm going to multiply those sides by 4. And that's going to end up being 72 root 3 equals x squared root 3. I'm going to divide by root 3. Something isn't working right with my math, and I'm trying to figure out where I messed it up. But you know what? I'm going to let God take care of this, and then we make sure it is working. Okay, so I think we're on the right page, right, my friends? If we multiply both sides by 4. Oh, guys, I see where my math was. Did you see what I did? If I simplify, that would be over 2, and this would be 36. I so need you guys in my classroom to make these videos so much better. But hey, at least we found the math there. Instead of multiplying both sides by 4, I should have multiplied both sides by 2 when we're simplifying. I can't multiply 3 by 4 for some reason today. All right, let's divide by root 3. So I get 36 is equal to x squared. I'm going to take the square root of both sides, but obviously I don't need the negative value for length, and it's going to be 6 units. We have to label. Okay, let's look at our last one here. Hopefully I don't mess up quite so much, but I need to find the radius of this cone, and this is an oblique cone, but that's okay because volume, because of Cavalari's principle, we can do this. So the volume of the cone is going to be pi r squared, the area of the base of the cone, times its height all over 3. So we're going to plug in and work backwards. So we have 24 pi is our volume. Radius we don't know, but the height we do know. The height on this time is on the outside, which is 4 all over 3. So I'm going to multiply both sides by 3. And this is going to give me my 72 pi equals 4 pi times radius squared. Just simplify things on the right. I'm going to divide both sides by 4 pi. So what is 72 divided by 4? That's going to be 18. So I get 18 is equal to the radius squared. Then I take the square root of both. And the radius is going to simplify down to 3 root 2 units. All right, guys, I hope this helps you with working problems you might have missed on your homework. But remember, you can also give me a call, and I'm there to help you. And I look forward to seeing you in our Zoom meetings later this week.